Now, in R2, in two-dimensional space, if I have an equation like y equals 3, what does that equation describe? That equation describes all the points that are at a y value of 3. It defines a line in two-dimensional space. So we might ask the question, in three-dimensional space, what do I describe if I write an equation like y equals 3? So now we're saying y equals 3, what are all the points in space that have a y value of 3? Now over in two-dimensional space, x could vary, keeping y constant, and we get a line. Here, if I tried to describe all the points with a y value of 3, well, z could vary up and down, and x could vary either direction, or both could vary, so I could end up somewhere up here. And in fact, it ends up that we describe an entire plane of space when we describe y equals 3. I drew it here as a perspective rectangle, but it really does extend out forever in the z directions, and in the x directions, y is just constant. So y equals 3 here is describing a plane. Likewise, what would y equal 0 describe? Y equals 0 would describe all the points where y is 0, and would include the x and the z axes. That would be the plane y equals 0. And this is called one of the coordinate planes, kind of like we have the axes, the x and y axes here. We have the x, y, and z axes, but we also have the coordinate planes. So when y equals 0, we get the plane that includes the x and the z axes, and so this is sometimes called the xz plane. It is the plane that includes the x and the z axes. So likewise, we could talk about the yz plane and the xy plane, and so let's take a look at those. So if I have my xyz coordinates here, what would the xy plane look like? Well, the xy plane is the plane that includes the x-axis and the y-axis. And so that is this plane. It is the plane that would correspond to the floor if we're imagining the x and the y-axis going horizontally and z going up. What would the, so that was the yz plane, so what would the yz plane look like? Well, the yz plane would be the one that includes the y and the z axis, and it would be this one out here, right? Including the y and the z axis where x is 0, right? Over here, this is where z is 0. Okay? Those are the coordinate planes. Now notice that there are 3 of them, and then if we drew them all in, they would divide the space up into 8 pieces, right? 1, 2, 3, 4 on either side of the xz and x and yz planes, and then 4 more below the xy plane. And those are called the 8 octants, kind of like we talk about the 4 quadrants in two-dimensional space. Okay? And so the coordinate planes divide space up into 8 octants.